Okay, so here's our problem we're going to work on. Take a moment and read it. And we're actually going to work on this number 6. Okay. Now, we want to find the Maclaurin series for f of x, and we want to use the definition of Maclaurin series. And then the second part of the question asks us to find the associated radius of convergence. Now, just as a refresher, this should be in your notes. The Maclaurin series is the Taylor series with the center of A. So, what happened? I don't know what happened there. Ah, okay. So let's add a page below. And let's go ahead and get started. So our f of x is natural log of 1 plus x. And now we've got our formula for the Maclaurin series. So we can get started. So our f of x is natural log of 1 plus x. And the general format for Maclaurin series is going to be f of x equals f of 0 plus f prime of 0 x plus f double prime of 0 x squared over 2 factorial plus f triple prime of 0 x cubed over 3 factorial plus the fourth derivative of 0 x to the fourth over 4 factorial plus dot dot dot. And we can write that as a sum n equals 0 to infinity, the nth derivative at 0, x to the n over n factorial. So what we need to do is we need to figure out these coefficients. So we need to figure out f of 0, f prime of 0. Let me highlight. Here's what we need to know. F of 0, we need to compute f prime of 0, f double prime, f triple prime, the fourth derivative at 0, and ultimately get a formula for the nth derivative just by observing the pattern. And then once we have these coefficients, we can plug them in and we'll have our answer. Okay, so f of x is equal to the natural log of 1 plus x. F prime of x, 1 over 1 plus x. F double prime of x. Well, now let's see here. So this is 1 over 1 plus x, and I'm going to write this as 1 plus x to the negative 1. And now I'll have negative 1 plus x to the negative 2. What is the third derivative of x? It is, so now I'm going to do chain rule. So this negative 2 is going to come down, right? So I have 2 times 1 plus x to the negative 3. And now what about the fourth derivative of x? That'll be negative 3 times 2 will give me negative 6, and then 1 plus x to the negative 4. And then the fifth derivative is going to give me negative 4 times negative 6. So I'll get 24 times 1 plus x to the negative 5th. Can you see the pattern? Do you see the pattern of what is the nth derivative? So this is 2, 1 plus x to the negative 3. This is negative 6, so it's negative 2 times 3, 1 plus x to the negative 4. This is 24, which is 2 times 3 times 4 times 1 plus x to the negative 5. So we see that we're alternating because this is negative 1. We're alternating, and then each time we're multiplying by 1 more. So it looks like for the fifth derivative, this looks like 4 factorial. For the fourth derivative, we've got a 3 factorial. For the third derivative, we've got 2 factorial. For the second derivative, we've got 1 factorial. So we're keeping these things in mind. As we now, let's go ahead and we're going to, just like we came up with our list of f, the derivatives of f, now we need to compute f of 0. F of 0 is going to be natural log of 1 plus 0, which is natural log of 1. What's natural log of 1? 0. 1 should be positive 6 factorial. The 8th derivative at 0 should be negative 7 factorial. Right? Do we see the pattern? What should the nth derivative at 0 be? Well, it's going to have an n minus 1 factorial. And then it'll be negative 1 to the n plus 1. Okay? So we can take this and plug it into this formula to get our Maclaurin series. So f of x, which is equal to the natural log, natural log of 1 plus x, is going to be the sum. Now, instead of the nth derivative at 0, we're going to put in negative 1 to the n plus 1 times n minus 1 factorial. Okay, for our numerator. The denominator is going to be n factorial over n factorial. Then we have times x to the n starts at 0. Okay. Now we can do some combining, right? Or reducing, I guess is a better way to say it. Because notice that n minus 1 factorial over n factorial is the same as 1 over n. So n minus 1 factorial divided by n factorial is the same as just 1 over n. Why is that true? Okay, n factorial means 1 times 2 times 3 times 4. And you keep going and you stop at n minus 2. You stop at n minus 1, right? That's how you get n minus 1 factorial. How do you get n factorial? 1 times 2 times 3 times 4. Da, 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 da. You're going to keep going to n minus 1, and you stop at n. So all of these terms back here, all of the terms less than n minus 1, are going to cancel out with the n minus 1 factorial. So what you're left with is a 1 on top and an n on the bottom. All right, so we can rewrite our Maclaurin series as the sum, n equals 0 to infinity, negative 1 to the n plus 1, x to the n over n. And that is our final answer. Okay, so the next part is, the next requirement is to, we want to find the radius of convergence. I think it said find the radius of convergence. Find the associated radius of convergence. So this is negative 1 to the n plus 1, x to the n over n. Okay, so we've got negative 1 to the n plus 1, x to the n over n, and we want to know what is the radius of convergence. Or this should be from 1 to infinity, actually. So I believe, let's go back here. So this n, we need to erase this, and this needs to be a 1. Because when n is equal to 0, notice that f of 0 is equal to 0, so this term is just going to be 0. So we can start our series at n equals 1. Okay, so we want to find the radius of convergence, and in order to do that, we need to look at, we can look at the limit of the ratio. So we're going to let L equal the limit as n goes to infinity of negative 1 to the n plus 2, x to the n plus 1 over n plus 1, divided by negative 1 to the n plus 1 over x to the n over n. We take the absolute value, okay, and this is equal to the limit as n goes to infinity. So now the negatives will cancel out because we're taking the absolute values. So we'll just have negative 1, and then the x to the n and the x to the n plus 1 will cancel out. So we'll have negative 1 times x. The n will flip over n for n plus 1, absolute value. So we're going to get the limit n goes to infinity of the absolute value of x times n over n plus 1. We can bring that absolute value of x outside. Limit n goes to infinity, n over n plus 1. But what limit? This is equal to 1. So we just get the absolute value of x. So L is equal to the absolute value of x, right? L is equal to the absolute value of x. So this series converges when...
I'm sorry, I don't have that information.
So Siri thought that I was talking. Don't even